Hello, my name is Jeff Durant, and this is my quality improvement presentation where I will cover the quality improvement project I completed for my company, Eastman Chemical Company. Eastman Chemical Company is a Fortune 500 company that has many different business segments. The facility in Fairlawn, Ohio is a research and development facility focusing primarily on tire additives. Within this facility, there are many laboratories, and I am the team manager for the rubber laboratory, where we work with both internal and external customers to perform experiments consisting of physical and mechanical testing of compounded rubber. The rubber laboratory is facing the pressures of having an increasing number of customers while keeping our headcount the same and still being expected to perform high quality work and generate high quality data. As the laboratory compounds rubber, inventory management of raw ingredients is critical. There is currently an inefficient system in place which requires multiple people to manually verify the chemicals needed for the formulation of the experiment in the inventory. This produces waste associated with overprocessing. Additionally, since important business decisions are being made from the results generated in the rubber laboratory, the raw ingredients need to be of high quality, free of decomposition and contamination. One way to assure the quality of the chemicals is to check the shelf life. Currently, the shelf life is only stored on an Excel sheet, so checking them will require logging onto a computer, opening the sheet, and verifying, which is very inefficient. Finally, the chemical cabinets used to store the raw ingredients are extremely cluttered, which generates unnecessary time spent searching for chemicals. This introduces other levels of waste, including employees waiting for others to find the chemicals, unnecessary transport of chemicals, and unnecessary movement of the employees. Also, it generates the potential for excess inventory. To begin the quality improvement process, a team was formed which included members of various rank and seniority. Members from outside the laboratory were also part of the team because they present fresh eyes onto the problem to help identify the most effective method. Once this team was formed, the scope was identified and a plan of action was developed. The scope was identified as improvements to the inventory verification process, improved shelf life verification, and improved chemical storage. The team then performed lean methodology, including 5S, to assess the problems and develop remedies. The plan of action began with assessing the problem and where the potential waste is introduced. To do this, the team developed a flow diagram. In the process of inventory verification, through the use of the flow diagram, the team was able to identify 2 steps that appear to be redundant and could be eliminated with better software. Using the 5 Whys approach, the team developed the root cause for the identification of issues of the inventory verification and chemical storage. The root cause for both situations proved to be lack of knowledge. This is likely attributed to the old saying, "This is how we all have always done it." From analyzing the flow diagram of the inventory verification process, 2 steps were eliminated by introducing software that communicates with both the current inventory and the formulation. This software will verify the total amount of each chemical required for the experiment with the existing inventory and turn green or red depending on the availability of the chemical. To address the issue of chemical storage and shelf life indication, 5S methodology was implemented. In the sort stage, items in the cabinets were separated based on frequency of use. The items that were most infrequently used were placed in secondary storage outside of the lab, and the frequent items were sorted in the lab by alphabet. In the set in place stage, secondary containers of the chemicals had color tape wrapped around the top, which corresponded to the shelf of which they are to be stored on. In this stage also, the shelf life stickers were placed onto the secondary containers which stored the chemicals to provide information that can be readily available before the chemical was used. This helps ensure that the chemical is of highest quality. Within the shine stage, shelves and cabinets were cleaned to prevent cross-contamination. In the standardized stage, training for the employees was offered so that the first 3 steps could be maintained. This will help ensure that the correct chemicals are replaced after use in the correct location to help with the ease of search. Sustainability will be determined at a later period. Based on literature, it is the intention of the team to implement 5S in accordance with the PDCA cycles, as this will help with the continual improvement of chemical storage. It will be analyzed what worked well and what did not, and the cycle will be repeated to make the changes as necessary. Most of the indicators of performance for this quality improvement project will be qualitative, based on feedback from the customer or employee. Once the inventory verification software is in operation, customer feedback will be gauged to determine if there is a time-saving and ease-of-use capability, or if it's requiring more time. Employee feedback will be used to determine how 5S is working and if we can make it better. It was determined by the team that weekly, the number of samples placed back incorrectly should be recorded to determine if retraining is necessary or to help with potential backsliding. This will also increase the potential likelihood of sustainability of the 5S methodology. The time spent looking for chemicals before 5S per a certain experiment type was recorded, and this will be compared at a later time after 5S has been implemented. Also, the team will monitor the use of the shelf life stickers. The way the team had thought of monitoring this was by placing a couple of stickers incorrectly labeled to show expired chemicals on frequently used items and see if the team members in the laboratory catch this before using the chemical. Thank you very much for watching this quality improvement project, and I hope you've learned a lot.